Yes. Now, what makes them special are their angle measures. So when you say, oops, not the right color. When you say special right triangles, it refers specifically to a 45, 45, 90 triangle and also a 30, 60, 90 triangle. So first we're going to be going over a 45, 45, 90. Now, what type of triangle is this? It's a right triangle. What else do you know about it?
Absolute.
It's isosceles.
It's isosceles. Shh. You making me regret keeping you guys together?
No.
No? Okay. So, the whole reason why these are considered to be special is because no matter what, if you have a 45, 45, 90 triangle, their side lengths are always going to have the same exact relationship. So, whenever you see you have a 45, 45, 90 and asks you to find the side lengths, you are always first, step one, going to draw a 45, 45, 90 chart. Just like this. And in that chart, on the right-hand side, you're going to put x, x, x square root 2. Can anyone take a guess as to where these values are located in comparison to the angles that they're in the same row as? So for instance, 45 is in the same row as x. What does that mean? Where are they located in comparison to each other? The 45 and the x. Yes. So if it's in the same row, it means that that value is across from the 45. So across from the 45 is an x. And if you have a highlighter, I would highlight that across from value. Or a marker, you can go ahead and circle. And across from the other 45 is what? Also an x. Whoops. And across from the 90 is what? X square root 2. Thank you. So that's step one, is drawing that chart. Step two is to fill in the side lengths. Fill in the side lengths the problem gave you. Fill in the side lengths the problem gave you into the chart. And step 3 is to solve for x and find the other side lengths. So, let's go ahead and try it on this next example. So the first step, the first thing you should do is recognize, okay, it says find the missing side lengths in the right triangle. And this is a 45, 45, 90 triangle. So I know I can apply the special right triangles chart. So that's the first thing, recognizing it's 45, 45, 90, and then drawing your 45, 45, 90 chart. Along with the values x, x, x square root 2. Now, what value does it give us? Which is across from what? So what do you think I'm going to do with that 8? Set the 45 side equal to 8. Now, do you think there's any solving needing to be done in this problem? No. What do they immediately give us? X is what? 8. So wherever we see an X, what are we going to put? 8. So across from the other 45 is also 8. And across from the 90, what is that value going to be? 8 square root 2. Good. Making sure we're putting those values back on the triangle. And we're done. Okay, so this next problem, what's our first step? Yeah. Good. First, identify it's a 45, 45, 90, and we're trying to find the side lengths. And that tells us we must draw our 45, 45, 90 chart. Now, is there a way to probably do this without drawing the chart? Yes, but I feel like keeping this organization is just, it's going to help you, especially when the problems get harder. So we have 45, 45, 90. What values do I fill in here on the right-hand side? X. X. Good. X square root 2. Now, which side did it give us? The side across from the 90. So, do you think that this means X is equal to 12? No. What does it mean? X square root 2 is equal to 12. So what do you think we're going to have to do here? Oh, we're actually going to have to solve for X. Yes. Now, how can we get X by itself? So yes, I could probably square this and get X squared times 2. However, in the end, in order to get X by itself, I would then have to square root our answer, which it's doable, but it is a lot more work versus what else can I do? You can divide by the square root of 2. Yes, the square root of 2 is just a number. It's just a value on the X being multiplied times X. So to get it off, the opposite of multiplication is division. Now, here's the issue. Have you ever seen a radical in a denominator before? You should not have, because actually this is illegal math. To leave an answer with a radical in the denominator is not mathematically correct. So we have to try to get the radical out of the denominator. Does anyone know how we can do this? Okay, how?
You could multiply. Yeah, the bottom and the X.
Do what?
Oh, what do you think? Oh.
No, because then we would have to also square X.
I know.
What?
We could try like doing. No.
Oh, I know you can get it. Every class, one person was able to get it.
What was the question?
How? Close.
Divide by 2.
Multiply by what?
Square.
Ah, why would multiplying by the square root of 2 help us here? Yes, Sean.
It'll cancel out the square root.
Ah, now, do you think I can just multiply it by the square root of 2 and have it be the same magnitude, have it be the same value? Or is it going to change in size if I just multiply by the square root of 2? It's going to change its size. So instead of just multiplying by the square root of 2, what would you do here? What can you always multiply by and it not change in size? 1. What has a square root of 2 in it that is equivalent to 1?
Square root 2 over square root 2.
Boom. We multiply both the top and the bottom by the square root of 2. Because what is the square root of 2 divided by the square root of 2? 1.
Square root of 2 times square root of 2 is 2.
So 12 times the square root of 2 is just 12 square root 2. And what is the square root of 2 times the square root of 2? Ah, and what are you left with? Just a 2.
No, it's not square. Just take it. No one just.
That is a lot more complicated. Yeah, you can do 6
And then divide by 2 and 2x times 2x equals 2.
No, because then you'd have to know divide by 2 and yes, Olivia. So that's our next step. Can this be simplified some more? Yes. What goes into both 12 and 2? Yes, 2. How many times does 2 go into 12? And how many times does 2 go into 2? Am I also going to simplify the number inside the radical? Why not? What have I already divided a 2 out of? Okay, so this is an important concept because I don't want you just to think, oh, never touch the radical. No, that's not the case here. I already divided a 2 out of the 12. 12 and square root of 2 are one term being multiplied together. So if I simplify both the square root 2 and the 12, I'm double simplifying. I'm taking actually 2 2's out of one term. That makes no sense, right? Okay, so our answer here is just 6 square root 2. Now, is that the end? What do I have to do with that 6 square root 2? Ah, so now I know if x is 6 square root 2, wherever I see an x, I'm going to put 6 square root 2. So that means the sides across from the 45 are 6 square root 2. Is it me or is it like hot in here?
It's very hot.
Any questions on this problem? As we keep going, you're going to see that this is it. You know, it may seem like a lot right now, but it's really not. It's the same process every time, okay? So, 30, 60, 90 is the same process, but with different numbers inside of your chart. So instead of having 45, 45, 90, we're going to have 30, 60, 90. Whoops, not 30, 60, 30. And instead of having x, x, x square root 2, you're going to have x, x square root 3, 2x. So this means across from the 30 is a what? An x. And across from the 60 is what?
Is this just what we have to memorize?
Yeah, you do unfortunately have to memorize these charts. Yes, Sean?
Why do you put 2x? Like where the 90 is?
Yeah, right here, 2x. You're asking why? Or no, where?
Like in the chart. I thought it was supposed to be x
square root of 2.
So it's changed. It's no longer a 45, 45, 90. This is now a 30, 60, 90 triangle. So it's changed. You have to memorize 2 different charts. Yes. Yes, Tamraz. So we could prove this. Someone discovered this using trig and the Pythagorean theorem. So eventually when we've learned trig, maybe we'll come back to this and we'll prove, okay, why are these values always true? Okay? All right. So let's try it. Find the missing lengths in the triangle. And this is a what triangle? 30, 60, 90. So we're going to draw our 30, 60, 90 chart. With x square root 3, 2x. Now, what value did it give us? Which is across from the 90. So, does this mean x is equal to 8? Ah, I now need to solve for x. How? What do I do here? Yes, you get the 2 off of the x by dividing by 2. What is 8 divided by 2? Now, is this all I have to do? Am I done? Yes, I now need to take 4, and wherever I see an x, I'm going to replace a 4. So across from the 30 is 4 units long. Across from the 60 is how long? Yes. Now, if you're good at memorizing, if they give you the hypotenuse is 8, you're going to know across from the 30 is half of that, and across from the 60 is a half times square root 3. Or just know how to work the chart.
This doesn't seem that hard.
So this is the second hardest problem right here. No, third hardest.
Wait.
Second hardest was the one we did over here. First hardest is this one we're about to do.
So,
Yes.
Are we supposed to solve this with trig, like after?
So, good observation that yes, eventually you could solve these instead with trig. However, what they love to do to you on the SAT is they'll give a problem like this on the non-calculator. And you're going to learn it is well, not impossible, but we're not going to sit here and memorize every single sine, cosine, and tangent operation. So for you, it is going to be impossible to do this on non-calculator if you don't know how to do special rates. Okay? You do have to memorize this, yeah. It's going to be on our quiz, yeah. Your quiz, so today, it's probably going to be Thursday. No, is today Friday? No, what is today? Wednesday. Oh my gosh, I'm way off. Tuesday. All right. So now that we're off track here, how do I start this problem? Make your chart. 30, 60, 90 chart. With, what are the values in this chart? X. Good. And what side do they give us? So I'm going to set the 60 side equal to 5. Do we know what x is yet? What do you think I'm going to have to do? Oh, math, yeah. So, how can I get that square root 3 off of the x? Ooh. Divide by the square root of 3. Now, is this mathematically correct as it is right now? No. Yes. Again, how do we get the square root 3 out of the denominator? Yes, multiply both the top and the bottom by square root 3. So we have 5 square root 3 over. So this means that x is 5 square root 3 over 3. There is no more simplifying I can do here. So wherever I see an x, what am I going to put? Good. Now, why is this problem just a little bit harder than the problem we had with the 45, 45, 90? Ah, you also need to multiply by 2. How do we do that?
And then simplify.
Good. So we're not multiplying the 2 times the denominator. We're multiplying the 2 times the numerator, right? And am I multiplying the 2 times both 5 and square root 3? No, that would be double multiplying one term. Just multiply the 2 times the 5 and you get 10 square root 3 over 3. So this means across from the 90 is 10 square root 3 over 3. And across from the 30 is 5 square root 3 over 3. Did I lose anyone? Almost? We came very close to losing someone? Yes. Well, all right. Hold up. Fold this paper in half. And on the front of it, I do want you to do a practice problem. Barkov. All right, guys, go ahead and solve this problem on the blank side of one of your folded edges.